Right, welcome back. Try a different lighting scheme so maybe you can see what's written here a little bit easier. But now we're going to get into section 4.4, which is adding and subtracting. So now it gets a little more interesting. The biggest caveat with adding and subtracting fractions is that the fractions have to be like. And like fractions are fractions that have the same denominator. So that's the only way we can add or subtract fractions, is they have to have the same denominator. There's no way around it. When they're the same though, it's a very nice, easy process. So take, for example, if we got 2/7 plus 3/7. All you're doing is adding the tops. You do not add the bottoms. So that would give you 5/7. So 2/7 plus 3/7 is 5/7. Likewise, if we're subtracting 3/5 minus 2/5, all you're doing is subtracting the tops, and you end up with 1/5. So you got to be a little careful because you're not doing anything with the denominators once they're the same. With multiplying and dividing, you are combining the tops and the bottoms. So you got to put it out of your head that you got to do it that way. So let's try a bunch of problems with the denominators that are the same. So if we got 37 over 103 minus 17 over 103, what do we get for an answer? And remember, we want lowest terms. So in this case, all you're doing is subtracting the tops. Now I like to write out extra steps, but if you're comfortable with this stuff, obviously write as much as you want. So in this case, all you're doing is subtracting those. Again, we do not do anything with the bottoms. We just carry whatever it is underneath all of it. So 20 over 103. And that's it. Now, we would try to reduce that if we could, but we can't. So that one's done. Let's try the next one. So we're adding two fractions, but now this negative here, how do we take care of that? Well, it turns out, remember, you can put a negative anywhere in front of the fractions. You can put it in front of the fraction bar the way it is. You can put it up in the top, or you can put it in the bottom. So I'm going to say let's move it up to the top. And that way we can rewrite it like this. Negative 11 plus 4 all over 12. And so now we just have to be careful when we combine negative 11 plus 4. If we use our rules, we know we're subtracting them. But because the negative is a bigger one, it's going to be negative 7 over 12. So negative 7 over 12. Done. Okay. 9 over 25 minus 14 over 25. So same as before. Let's just write 19 minus 14, or excuse me, 9 minus 14 over 25. What's 9 minus 14? Well, 14 minus 9 is positive 5, so if we reverse it, it better be negative 5. So we got negative 5 over 25. And we're done? No. We're going to have to reduce that. 5 goes in. So negative 1/5 should be our answer. All right. How would we write this one? Again, try to follow the same process as we did on the previous ones. So let's move the negative up, and then move the negative up, and put it all over the same denominator. And now, negative 7 minus 15. Well, that looks like it should be negative 22 over 33. And are we done? We can divide by 11. So negative 2/3. X's again? Well, yeah. Unfortunately, they're never going to go away. But how do we tackle it, though? The one thing you should notice, though, is that the denominator is the same. So we should be able to treat it the same way we did the previous ones. So what did we do? We took and just combined the tops, sort of like what we did up above. So you should have 12 minus 4, but it's all over x. Remember, you don't combine the bottoms at all. You just carry it, whatever it is. So that's what we're going to do here. And so now 12 minus 4 is x, or 12 minus 4 is x. 12 minus 4 is 8. So that should be your answer, 8 over x. Okay, what about on the top though? Same as up above. X minus the 11. The 12s, we just carry it and have a 12 underneath. But now how do we combine the top? How do we make it more compact? Now some of you might say, oh, well, isn't it just going to be negative 11x over 12? That's a common answer, but it's not right. That is not going to be the answer. You can't combine those. Think of it like apples and oranges. You have one apple minus 11 nothings. You can't combine apples and nothings together. So that's the problem. So your answer is x minus 11 over 12. I know, it's not very satisfying, is it? But, well, so that is what happens when the denominators are the same. But of course, that's not real life. What happens when they're different? Well, now we got to do a little adjustment to the problem. And it's all based off of the LCD, or the least common denominator. So we're trying to find a denominator that both of them go into. So usually it's going to be something bigger than either one of them. Sometimes it's the same as one of them, but oftentimes it's going to be bigger than both of them. So let's look at this example. We have 5, 6 minus 7, 18. So 18's the bigger one, but 6 goes into 18 evenly. So we can change this 6 into an 18 by timesing it by 3. But if you times the bottom by 3, you've got to times the top by 3 as well. Now you've changed it. It's still the same fraction. It's still equivalent. It's just got the same denominator as the second fraction now. But because they're the same, we can combine those. 15 minus 7 is 8. 8 over 18 reduces down to 4 over 9. So it's an extra step in the process. You got to get those denominators the same. Now, sometimes this process is a little confusing, so we're going to break it out as far as finding the LCD before we start adding and subtracting. So if we got 1/4 and 3/8, and we want a common denominator, what would that common denominator be, that least common denominator? The answer is 8. And the reason why is because 4 goes into 8 evenly. As soon as you can see that the smaller one goes into the larger one evenly, you're done. That is your LCD. So what happens when it doesn't occur? 3 and 7. Well, 3 doesn't go into 7 evenly. So what do? Well, here's my little trick. I take multiples of the larger one and see when the smaller one goes in. So 7 times 2, or 7 plus 7, is 14. Because, like I said, 7 doesn't work, so we can cross it out. Does 3 go into 14? Nope. So what's the next multiple after that? So 7, 14, then 21. Does 3 go into 21? Ding, ding, ding. It does. So that is your LCD. It's a little quirky of a process, but it always works. So that's the thing. Let's look at the next one. 12 and 15. Well, 12 doesn't go into 15, so let's take multiples of the 15. So the next multiple of 15 is 30. So does 12 go into 30 evenly? Nope, no good on that. What's the next multiple after 30? So 15, 30, 45. Yeah, 45. Does 12 go into 45? No. Man, are we going to get there? How about the next one? The next one is 60. Does 12 go into 60? Ding, 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 ding. It does. So your LCD is 60. So not a terrible process. Hopefully you're not going to have to do too many multiples before you find where it works. Sometimes it's quick like the first one. So it's going to depend. Let's just do these last two and then we'll stop this video and pick up the last bit of it in the next one. So we got 9 and 21. Well, 9 doesn't go into 21, so let's cross that out. Next multiple would be 42. Does 9 go into 42? No. Next multiple would be 63. Does 9 go into 63? Ding, ding, ding. So that is your LCD. All right. Ooh, what about when there's 3 fractions? Ooh. Well, here's a trick. See if any 2 of them pair up nicely. So in this case, 9 and 18. 9 goes into 18 evenly. So whatever works for 18, 9 is going to be satisfied. So we really don't care about the 2/9. All we care about is just these 2 fractions. Now you're probably saying, well, what if none of them match up or pair up nicely? Well, then you go back to what we were doing. Take the largest one and take multiples until they all go into it evenly. So in this case, 18 doesn't go into 24. Next multiple is 48. 18 doesn't go into 48. Next multiple is 72. Does 18 go into 72? I believe it does. It goes in 4 times. So that is going to work. And we can also see that 9 goes into 72 evenly as well. So our LCD is 72. Okay, so now that we know how LCDs work, how do we actually do the whole process? And you'll see that in the next video.